At the first minimum adjacent to the central maxima of the single slit diffraction pattern, the phase difference between the Huygens wavelet from the edge of the slit and the wavelet from the midpoint of the slit is what? Okay, we'll draw the diagram here. Let us first we'll draw the screen. This is the screen, and here a single slit is there. The single slit is there here, and this width of the slit we can take it as a A. This is the width of the single slit. This is the width of the single slit. This is a single slit and width is A here. Okay, from here the first minima, it will be moving in this direction. The minima, the first minima, it is the locate the point P. We can locate the point P here. Okay, and this is the central axis and this is central maxima or the first minima here. And we can draw the perpendicular line. That means from here, what is this one we need to find here? So this one I am going to draw the line perpendicular to this line. A perpendicular line of this one, this is 90 degree. This is 90 degree. And this angle is equal to the theta. And this is distance is A by 2 is the distance. That is width is equal to half of the distance is A by 2. Okay. Then with this data, we can write the single, that is the sine theta is equal to, that is this distance, that is the base, this is equal to, this distance is equal to the delta x here. Then sine theta is equal to delta x divided by A by 2. Then delta x is equal to A by 2 sine theta. Then we can write for minima, A sine theta is equal to lambda. Then delta x is equal to A by 2 sine theta is there. That we can write as lambda by 2. If delta x is equal to pi by 2, then delta 5 is equal to 2 pi by divided by lambda into delta x. Then delta 5 is equal to 2 pi divided by lambda. Delta x is nothing but lambda by 2. If I substitute that value lambda by 2, then 2 will get cancelled. Lambda will get cancelled. Then delta 5 is equal to pi radians. Then the answer option D is our right answer.